Okay, I wonder what target to do tonight. I'm trying to see what a good target is, and
why don't you image some tadpoles?
where'd you come from?
The pond.
Fair enough. Well, what target do you suggest?
I said some tadpoles.
The Tadpole Nebula is in the Northern Hemisphere.
No, you dummy. I'm talking about the Southern Tadpole Nebula.
Oh, Southern Tadpole Nebula. Do you know where that is?
Yep.
Okay. Do you know the number?
Oh, it doesn't have a number, but there's a star cluster with it.
Okay, what's that?
NGC 3572.
Oh, okay. I'll type that in. So NGC 3572. Is that correct?
Yep.
Okay. Oh, it's near Carina. Zoom in. Aha, there's the cluster and is that the tadpoles?
Yep, that's him.
Oh, okay. Oh, I'll do that. Thanks very much for your advice.
You're welcome. I'll go back to the pond now.
Okay, see you later.
Bye-bye.
So it turned out that I had actually already imaged the Tadpole Nebula, well, a little bit of the Tadpole Nebula, in a session where I was imaging the Statue of Liberty Nebula. And rather than having the Statue of Liberty sitting in the middle of the frame, I thought, why not put it a little bit to the bottom? And there was some nebulosity above, which I thought would look quite nice in the image. Turned out it was part of the Tadpole Nebula. So I've got Nina all set up here, and the cameras will cool down to -10 degrees, as you can see there. And I have actually, this is the sequence I've got set up. You can see roughly where the target is with regards to the fact that we are a little bit past the best already. It is starting to head down by the time we hit astronomical darkness, but I have been capturing some beforehand in between bouts of bad weather, so this is sort of more finishing it off, to be honest. And you can see actually here's some of the S2 that I did, OIII I did one night, but tonight I'm going to do some HA and might flick onto S2 if I've got some time and maybe go around that lot again. Just to show you the framing, this is the framing that I've got, so I've just loaded in one of the previous frames, and the tadpoles are just down here, so they're not quite as dramatic as the tadpoles of the Tadpole Nebula in the Northern Hemisphere, but they're our little version of them. So yeah, just got to wait till we get into darkness, and then hopefully you can capture some more HA. So I'll check back once we're up and running. Okay, so it's found the target. You can just faintly see it in here on the HA. And it's now going to run through an autofocus. And hopefully the guiding will be alright tonight. It seems to vary quite a lot at the moment, but we'll see how it goes.
A few moments later.
Okay, so as you can probably tell from the video, that session was cut short really even before it started, with the clouds coming in and the rain. And as the weather forecast is pretty much shot for the next 10 or 12 days, or probably longer, with some storms coming through, lots of snow down the South Island, I thought I might as well go ahead and process what I had. So let me just run through quickly. This is the OIII stack, and this was 17 10-minute exposures, so just a little bit under 3 hours. This was the S2, also 17 10-minute exposures, again just under 3 hours. And I spent most of the time on the HA since it had the most detail in it, and this is just shy of 8 hours. Again, 10-minute exposures. So all up it was about 13 and a half hours once it was all combined. So I did various combinations and, ended up settling on the usual SHO. And I wasn't going to go through all the processing of it. I just wanted to talk a little bit about some of the things I've noticed when I've been using Star Exterminator versus Starnet, and then also talk about a little interesting feature that's actually in this image, which has educated me. So this is what basically effectively what it looked like once it was combined. And I removed the magenta stars and also did a SNR with removing a lot of the green. And I basically went ahead and sort of processed it in PixInsight and Photoshop to bring up my final image, which I'll show you shortly. And I used actually the, if we come over here, let's come back, the HA as the luminance channel. So just bring that forward again for a minute. Now, I have been experimenting with both Starnet 2 and Star Exterminator because I've been finding that in some areas it's better to use one versus the other. Now, my original thought when I first sort of went through and looked at Starnet 2 versus Star Exterminator, felt that Star Exterminator was by far the winner. I had been testing it on some targets with some very bright areas that Starnet 2 did struggle with, and did some sort of wacky things with, by throwing in like a bit of purple colour or whatever. But in other images where the star field is a lot more even and there's just the odd bright star, I've sometimes found it's better to use Starnet versus Star Exterminator, and I'll explain in a minute. So when it comes to this sort of image, and I actually stretched these obviously and combined them stretched, and I'm just going to jump forward and show you what Star Exterminator does. So here you can see nice and clean, it's removed all the stars basically. It's done a great job there. And if we look at Starnet and we just jump forward, you can see that it's still done a very good job, but it struggled with this bright star and this one over here. And again, when you're dealing with their stars have been removed, here's Star Exterminator. Again, nicely removed that bright star, and that's a very clean looking star removed. Starnet 2 on the other hand has, if we look here, you can see that that bright star is completely missing, and this one hasn't quite been removed so cleanly. So when you're dealing with the removal of the stars, to play around with those, definitely Star Exterminator is the winner. Now I'll just show you with Starnet 2 versus Star Exterminator, and the differences when it comes to the background and the star removal are pretty minimal between the two of them, I have to say, when you're dealing with a combined sort of color channels. And I'm just going to zoom in a bit closer here. I've gone backwards there. Let me just bring up to here, and we'll just drag this over to this one here. And if we look between these two, fairly similar. Star Exterminator on this particular instance might be a little bit smoother than Starnet 2, but not hugely different. And often you're applying a bit of blur to this before you apply your luminance anyway, so it's perhaps not such a big deal, any minor differences between these two. Where I have found the difference though is when it comes to your luminance data. Now here is I basically took the same luminance image, which was the hydrogen alpha, and this was at let me see, I've got this here, that's it stretched. These are both linear. Okay, so I've used Star Exterminator and Starnet 2 with the linear box ticked. And what I noticed was if we move into here, yes, Starnet has left these stars behind. It's done a little bit of a wacky thing with this bright star where it's put a little pinhole in it. But if you can sort of deal with that by putting a mask, dealing with masks later on. But one thing I noticed here was the background here was very, very clean and very, very smooth with Starnet 2. With Star Exterminator, I had this very blotchy background, and if I just zoom in a bit closer, you can see there's quite an awful pattern where the stars were. There's little outlines there, and you really don't want to be having to deal with that, because that you don't want to blur that out, because on the luminance you're trying to get as much detail as possible. You don't want to start blurring everything. And I found that quite annoying and hard to deal with when I was processing the luminance component, whereas Starnet 2, and let me just grab this here and just make them comparable. These are the same areas, and there's a huge difference here. And this is on the linear, if you're dealing with it, removing the stars linear. When it comes to, I've actually put these in the wrong place, I'm down here. If it comes to stretched images and you're doing the same thing with removing the stars, and you have the same situation, let me just show you here. So Star Exterminator here, removed all the stars nicely. Starnet 2, couldn't get rid of that one or that one. But again, with the stretched version, and let's just zoom in here. Starnet 2, a relatively smooth background there. And if we go to Star Exterminator, we find that there is this blotchiness is still remaining. It's not as marked as it is on the linear images, but it's not as smooth and clean as it is on Starnet 2. So I have been mix and matching what I use when it comes to star removal. And on some images, Starnet 2 works better than Star Exterminator. On the luminance data, I find that Starnet 2 works better than Star Exterminator. And obviously there's not a huge difference when it comes to the combined color component. So I just thought I'd sort of go through those things that I've noticed, and maybe you can leave in the comments your experience with how you found any differences between the two, and whether you've been noticing that sort of blotchiness in the background using Star Exterminator versus Starnet 2. It's a bit of a trade-off, because obviously one is nicely removing all the stars and leaving behind this sort of blotchiness in the background, and the other one is leaving behind some of the brighter stars that you then have to deal with. But you can deal with that with masks fairly easily, whether it be the game mask or whether it be you take it into Photoshop and you do your own mask. The other thing I wanted to talk about in this image was a little thing I've sort of just learnt about, and I thought it would be interesting just to talk a little bit about it as far as my understanding goes, because it was a little bit complex, the whole thing, including reading a few papers, but which were well over my head. But this is my final image, and it is an SHO combination, but using color masks, I made the more traditional sort of yellow and orange areas a bit more red, a bit more like normal hydrogen alpha that you might see in an RGB image. Now here's the Tadpole Nebula here. I think in the beginning I said it didn't have a designation. It actually does have a designation. It's actually called GUM 37, I've since discovered. And over here are the tadpoles, but how I found it was through this sort of open cluster here, which is let me just double check, it is NGC 3572, and what is noticeable in the middle of this little star cluster is this very sort of smooth oval looking bright object. This was very, very bright in the images right from the start, and this was first thought to be a planetary nebula, but the problem is obviously with planetary nebulas is formed by the fact there is a dying star in the center throwing off its outer shell of gas, etc., and then the radiation from that central star makes that outer gas glow. They couldn't find a star in the center of this, and sort of then why was it glowing so much? And what they've, I think, recategorized this now as a photoevaporating globule. What that means is the molecular cloud that was here, the dust, etc., from which these stars formed, which is the open cluster, these have sort of formed and then blown away a lot of the dust through solar winds and ionization, etc. But this is a remnant of that molecular cloud, still a fairly dense area of dust, which could still form some stars, probably some smaller stars, or a smaller star. And the reason why this is glowing is it's these big stars out here are ionizing it from the outside in, if you like. So rather than a planetary nebula being ionizing, glowing from the inside out because of the central star, these are being ionized from the outside in, and also being evaporated away. And I guess it depends on how quickly this evaporates away from these stars as to whether any other star will be able to form within here before it actually gets sort of blown away. So yeah, that was a term I hadn't heard of, a photoevaporating globule. I think they're also similar to Thackeray's globules, which we see in the Rosette Nebula, although they don't seem to be being illuminated by bright stars, so they sort of look dark, and you're seeing them like a silhouette on the bright nebulosity behind. But anyway, that was something I learnt, the photoevaporating globule. Anyway, I hope you enjoyed the video and maybe learnt something, I don't know. And if you did, maybe give us a thumbs up, and if you're new to the channel, maybe consider subscribing, as I'll continue to make more videos as I image more wonders of the night sky. And I'll leave you with a final view of the Tadpole Nebula and its little photoevaporating globule. So I'll see you in the next video, and clear skies.